I would like us to cover revision on the moles, specifically the topic empirical and molecular formula, and from KLB book 3, page 81. We are doing question number 12. I've chosen this question specifically because it has got a lot of challenges and most of the students usually get it wrong. So the question reads, a hydrocarbon has a percentage composition by mass of 87.8 carbon, the rest is hydrogen. If the relative molecular mass is 82, determine the molecular formula of the hydrocarbon. So before we get the molecular formula of the hydrocarbon, we are supposed to get the empirical formula. So we start by indicating the elements. The elements are two, carbon and hydrogen. Percentage composition, carbon is 87.8, which is this one. And the hydrogen will be now 100% minus 87.8, which we get 12.2%. The next is molar mass. Most people usually write relative atomic mass. We are supposed to write molar mass because it accommodates all, whether it is atomic mass, relative formula mass, or relative molecular mass. So molar mass is usually preferred because you cannot get it wrong. If you write here molar mass and it is an ionic compound, then you are actually right. But if you write here relative atomic mass and it is an ionic compound, then it will be wrong because it is a wrong commitment. You are supposed to write what? Relative formula mass. So molar mass accommodates all of them. That's why we are preferring to use molar mass instead of relative atomic mass, relative molecular mass, or relative formula mass. So carbon relative atomic mass is 12, that is the molar mass, it is 12. Hydrogen molar mass is 1. Number of moles. Number of moles is given by either mass in grams divided by molar mass or percentage composition divided by molar mass. So in this case, it will be what? 87.8, which is the percentage composition, we divide by 12, which is the molar mass. We get 7.3166, which is the current. That's why I'm putting a dot here and another dot there. 12.2, which is the percentage composition of hydrogen, divided by 1, we get 12.2. Now, where the challenge now comes in is in the part of mole ratio. Now, mole ratio, we divide by the smallest. So you get 7.3166 recurrent. We divide by 7.3166 recurrent. Here we get 1. And here we get 12.2. We divide by 7.3166 recurrent. We get 0.31666 recurrent divided by 7.3166 recurrent, we get 1. 12.1 we divide by the smallest, which was 7.3166 recurrent, is equals to 1.6667. Now, this is where now most of the students usually get wrong. If you say this is 1 and then you say this is approximately 2, that is wrong. You will not be able to get the what? The relative formula mass, which is 82, or the molecular mass, which is 82. Now the right thing to do, when you see 0.6666, then you multiply by 3. So here you multiply by 3, and here you multiply by 3. So the mole ratio will be 3 to 5. So the empirical formula, so here we have empirical formula will be C3H5. That's the empirical formula. But we want to get the molecular formula. So we write it like this. Empirical formula mass. Empirical formula mass multiplied by M should give us molecular formula mass. Now we already have the empirical formula, which is C3H5. So the empirical formula, which is C3H5 times N, should give us the molecular formula mass. And the molecular formula mass is 82. So it's equals to 82. So we have here 3 times 12 which is 36. 1 times 5, which is 5. All this times n should give us 82. The 6 plus 5 is equals to 41 times n is equals to 41n is equals to 82. We divide by 41, we divide by 41. So n is equals to 2. Now we take this n here and we open the bracket. We are going to have C3H5, we multiply by 2, which you are going to get what? C6H10. The reason why I picked on this one is because of this part. 7.316 and 12.2. When you get the mole ratio, we get 1 to, the mole ratio is going to give us 1 to what? 1.666, which is recurrent. When we get that, we don't approximate and say this 0.6 is above 5, and therefore it is what? A whole number. So most students will actually give me this to be 1.66 will be approximately 2, and this is 1. So if this could have been 1 to 2. If you use that, you will not get 82 as your empirical, as your molecular mass. So we'll continue in our next video. Now, most of you are asking, why are we multiplying by 3? How did we arrive at 3? So, give me the response in the comment section. Thank you.